Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. So this is lecture 20. We are in the last part of the normalization chapter. Before starting this lecture, you must have to watch the lecture number 19 along with lecture number 18 and 17. It will be very beneficial for you if you watch the last LMS lecture of that class, because there I have reviewed all of the three lectures. So let me start here. This is the Boyce code normal form. It is in short said BCNF. So a relation, a table is in BCNF if it is satisfied the following conditions. What are the conditions? It should be in the third normal form. In the previous two normal forms, we have seen that if a normal form in each and every normal form is following the previous normal form's regulations, so that BCNF should have to follow the rules of third normal form. So it should be in already in third normal form. Another thing is, for any dependency it aims to be, determinant A should be a candidate key. A candidate key is always a super key. So that is already cleared in the lecture number 16 and 17, that what is a determinant and what is a candidate key, and how a determinant is controlling each and every functional dependency, and how the object of determinants are controlled by the determinant, and if the determinant is deleted, how the relationship is impacted, if it is a partial functional dependency or a full functional dependency. Candidate key may be in the form of composite and overlapping. So candidate keys is maybe composite, that is mean more than one attribute can form a composite key, and overlapping, that an attribute may come in different candidate keys. So primary key is generated from the set of candidate keys. So there should be a candidate primary key that should be generated from the candidate keys is the regular rules. So now we are seeing a table. In this table there are three columns, that is the student ID, subject and professor. In the student ID there are basically here four students. Four students is enrolled in some courses, that is Java, C++, C#, and there are different professors. So in this table so far we have some information like one student can enroll for multiple subjects. Suppose like roll number 12111, he is enrolling in Java and also C++. For each subject a professor is assigned to the student. So each of the subject is a professor is assigned to a student. So each of the student having a teacher, multiple professors teaching one subject, like we have for Java. Here that is an example, that is Professor S and Professor W, both are conducting the course of Java. So a single course can be conducted by multiple faculties also. Who will be the primary key in this table? If we look this table, who can be a primary key? Student, subject or professor? Who is? Can we make a single attribute for this primary key, or we will take multiple? So if we make student ID and subject together form of primary key, then you should have that subject is a candidate key. As a subject is a candidate key, so subject is coming in a lot of times. A student may have take the same subject twice in different semester if he has not make a proper result. Because using the student ID and subject we can find all the columns of the table. Okay, so if you make subject and professor as a primary key, that should not be, because the same subject and professor is not all over there. But if you make the student ID and subject, that can form the primary key, because one student may have to take the course. If he is doing bad or the result is not satisfactory, the previous result will be deleted or it is not counted, so he can have to take this course again. So the student ID is again tagged with the subject code or subject name. So these two are making the primary key. So from here we are seeing some dependency. That is, there is a dependency between the subject and professor here, where subject depends on the professor name. So same subject is taken by two professor, Professor S and Professor W is taking the Java course. So subject is dependent on the professor name. So dependency is here that professor is in the determinant side and subject is in the object of determinant side, that is in the right hand side. So subject is dependent on professor. So student ID and subject form the primary key. Subject is also a candidate key. Here if we check this table according to the normalized form, so this table is satisfied the first normal form because all the values are atomic, that is all the values are single, column names are unique, all the columns names having different names, and all the values stored in the particular column are in the same domain, and the data are inserted in any fashion. So it is in the first normal form already. In the second normal form we can see that these table have no partial dependency. It is a full functional dependent table because the student ID and subject both make the primary key, and the non-key attribute is fully functional dependent with its primary key, so that the it is already in the second normal form, and there is no transitive dependency here, so it is already in the third normal form. So but this table is not in the Boyce code normal form. So because of why? Because Boyce code normal form says that the subject, the candidate key, the primary key should be a candidate key. So primary key should be a candidate key. Here subject is a candidate key, but student is not the candidate key. So that is the problem here. So how can we break the situation or melt the solution? So to make the relation, to make the table satisfy of the BCNF, we will decompose this table into two tables. First, student table and professor table. Below we have the structure of both the tables. First we take the student table. So we'll make the student ID and the PID. The PID, that is mean professor ID. Okay, so student ID and professor ID. So in the professor table, that is professor, there are four professor 1, 2, 3 and 4. So professor having some ID and he is taking some courses. So that is the comes from the professor table, and from the professor table we are taking this in the student table we are just passing the ID of the professor, so that here in the student table the student ID is the primary key, and so student ID is the primary key and PID is the non-key attribute, and as the student ID is a primary key, so it is already converted in the highest level. And in the professor table it is here the PID is obviously the primary key, so all the non-key attributes professor and the subject is dependent on its primary key. So that is the thing here. This table is completely converted in the BCNF relationship. So we can see another example on a different scenario, that is the client interview. In the client interview scenario, there are 5 attributes, 5 columns in this table. So that is the client ID, interview date, interview time, staff nong and room nong. There are different attributes. So each of the having some different type of data here. So in this data, it is mentioned here, that is the primary key and the candidate keys. So here primary key is the client ID and interview date. So client ID and interview date here is a primary key, and candidate key is staff name, interview date and interview time. These three makes compositely a candidate key, or we can say that room number, interview date and interview time, these also make a candidate key. So it is a composite candidate key. So these three attributes, staff name, interview date and interview time, these three makes the one of the candidate key, and another candidate key is room number, interview date and interview time. So here we found some functional dependency. There are 5 functional dependency, and in your exam you may find more than functional dependency, or you may have to create a functional dependency by you in the exam also. So here I am just giving 5 functional dependency, that is client ID, interview date, temps to interview time, staff name, room name, and staff name, interview date, interview time, and temps to client ID, room number, interview date, interview time, temps to staff name, room number, staff name, interview date, room name, interview date, temps to room number, staff name, room number, temps to interview time. So here here something, 2 things you have to understand, that is the primary key is client ID and interview date, and candidate key is the staff name, interview date, interview time, and room number, interview date and interview time. These 2 are composite, and whereas the primary key is client ID and interview date. So the rules is basically, in the book the rules is very much complex theoretical, but I can make a simple rule here. That is, whenever you are looking in the determinant side, you have to see that it is a candidate key or not. If it is a candidate key, then it is follows the rule. If it is not a candidate key, that it does not following the rules. So functional dependency number 1, if we're looking for the one, client ID, interview date, temps to interview time, staff name, room number. Here client ID and interview date is the determinant, and the right hand side is the object of determinant. So is the number 1 is determinant, is the number 1's determinant is a candidate key? Yes, because these 2 are the primary key. So primary key is always a candidate key. So primary key comes from the candidate key. So it is a candidate key. Obviously it is a candidate key. So number 1 is maintaining the rules. Number 2, staff name, interview date and interview time, temps to client ID. So in the determinant side, is it the candidate key? Yes, it is also following the rule. Rule number 3, functional dependency 3, that is the room number, interview date, interview time. Do it following the rules? Yes, it is also following the rules, because room number, interview date and interview time is a candidate key, and it is in the determinant side. And 4, staff name, interview date, is it a candidate key? No, because here only 2 attributes, these are not the candidate key. Here 1 is primary key, okay, but and there is not from the candidate key or primary key, so we cannot say that that is the candidate key. So 4 is not maintaining the rule. 5, staff name, room number. Here the determinant is not a candidate key or a primary key, so 5 is not maintaining the rule. So 4 and 5 is not maintaining the rule. 1, 2 and 3 is maintaining the rule. So from the main who are maintaining the rule and who are not maintaining the rule, there are 2 classes: class A who are maintaining the rule, class B who are not maintaining the rule. So from the class A, that is, I repeat, attributes which are maintaining the rule, we can make a table with the functional dependency, but we have to think that the same table should not be returned. I say again, that is the rules which are following the Boyce code normal form, that is the determinant side is a candidate key, or so by this functional dependency, if we create a table, the same table, the mother table, should not be returned. So if we look here, you see from 1, 2 and 3, these three are maintaining the rule, so these are in the class A. So in these 3, 1 and 3 having 5 attributes, whereas our mother table having the 5 same attributes. So if we making the table with these 1 and 3, that is client ID, interview date, interview time, staff nong and room nong, basically returns the same table which is the mother table. So that is again violating the rule, so it is not working. Only rule number 2, it staff nong, interview date and interview time temps to client ID, it is in the cluster 1 or cluster A, and it doesn't return the same table. As it doesn't return the same table, we can say that it can make a table from the cluster A. Another thing is who are not following the rules, from where if some rules are not following, so from there we have to follow that in the determinant side if there is any primary key or not. So in the rule number 4 and 5, there is in the 4, interview date is a primary key, but staff nong is not a primary key or a candidate key. So we can take these as a table, that is staff nong, interview date and room number as a table. But if there is no primary key in that rules, in that functional dependency which are in the cluster B, in that time you have to create a new primary key for them, which will be appropriate or which will be accomplished with the table that is missing from the mother table. That means that if you are create some table from cluster A, some attribute may be missing. So you have not miss, you cannot miss any attribute from the mother table, so you have to create another table for that attribute with some attributes. So for creating the new table, you have to choose from the cluster B, and you maybe need to identify a new primary key there. So what will be the solution here? The client interview date in this table, the interview date, staff nong and room number, we are taking these things, that is one table. So here interview date is the primary key, so it is maintaining all the rules. And in this table, client interview details, we are taking primary key as the client ID, interview date and interview time, because it is a candidate key. A candidate key can be a primary key. You see here, it is a very rational thing, is that a client may have interview. Okay, a client may have different interview in the same place on the same day. So if we take only client ID and interview date, then it can be repeated. Suppose C76 or C54 and C54 comes 2 times in a same date. So if we make only client ID and interview date as a primary key, then it will be create some chaos. So as when these people is coming two interview on the same date, we are specified them by some time, because two interview cannot placed in the same time, in the same room. That is the different issue, but not in the same time. It is very normal, it is very quite rational. That is, you cannot keep yourself two places in the same time. Either you are in one place or another. That is the thing. So that is very familiar. So client ID, interview date, and interview time, these trees compositely make the primary key and make this table complete, and make this table in the Boyce code normal form. So that's for all. Thank you all for this hearing this lecture, and this is the end of the normalization chapter. Thank you.